finally moving on to something new. We are going to talk about solving some equations today. We have exponential equations that we are going to focus on. Now, we have solved exponential equations when you had like 2 to the x plus 1 equals 16. And we knew that we could solve those by getting a common base. But the common base isn't always an option. So I want to take a look at a problem like this. 8 to the x equals 21. Okay, there is absolutely no way we can get a common base between 8 and 21. We could change this to logarithmic form. Log base 8 of 21 equals x, but I want to focus on things that we can use our calculator for. Now, certain calculators do let you put in the base, but some do not, and especially since we are all at home and using different calculators, we have to level the playing field. So, you are not allowed to use your calculator for anything except the log base 10 and the natural log. So I can't just say log base 8 because I'm telling you you can't put that in your calculator. Not all calculators will do it. What we are going to do instead is think about solving an equation. Whatever you do to one side, you have to do to the other. So I am going to add a log, but I'm going to put it on each side. I'm choosing to do log base 10, again, because I have that button on my calculator. You could also do the ln for the natural log. You'll get the same answer. The benefit of this is now we can use those properties of logs we talked about. If you have an exponent, we know that can come down in front. So this is x times the log of 8 equals the log of 21. If I'm trying to get x by itself, x is multiplied with this log, so you will divide the log. So x is log 21 divided by log 8. Now the homework tonight is going to be Math Excel, and it may ask for your answers different ways. If it says the exact answer, that's this with the logs. But it might also sometimes say give me the decimal. So if you don't have a calculator, pause this video and go grab one. And you are going to type this in. So I'm hitting my log button, opens a parenthesis, so I do log 21, close my parenthesis, divided by log 8. And you should get 1.4641. I'm going to ask you to round those to 4 decimal places. I believe the Math Excel does the same, but just watch. It will specify in each question how many decimal places it wants you to round it to. So in Math Excel test or quiz, I will always specify if I want the exact value, so just leave it in terms of logs, or if I want you to give me a decimal. Okay. Now, just like we talked about with the common base, you had to have just one thing on each side. If you're going to add a log, you really just want one term on each side of the equation. So when I'm looking at this, I see my 2 to the x, that's where I have the exponent. I need to isolate that. So I'm going to first subtract my 3 over. Divide by 6. So we have 2 to the x equals 30. Do a quick check to see if you can get a common base, because that might still be an option. But unfortunately 2 to some power does not equal 30. So we add the log to each side. Exponent comes down. And so then we divide. So x is log 30 divided by log 2. That's your exact value. If I asked for the decimal, type it in your calculator. If you do not have a calculator at home, you may use Desmos right now. and you should get 4.906. You round up to a 9. So make sure you round appropriately. And you can check these just by plugging it into the original. Keep in mind, since I did round my exponent, it won't turn out to be exactly 63, but it should be very close. Let's try some more. Okay. If you're paying attention, you can answer this one from the beginning. First of all, we do know that 2 to the third power equals 8. But will you ever do 2 to a power and get a negative answer? And the answer to that is no. So if you realize that, you could stop right here and say this is no solution. I will never do a positive number to a power and get a negative. If you didn't catch that, that's okay. We can still get there. If I added my log, so the x minus 5 comes down. When you bring that down, keep it in parentheses. So I will divide by my log 2. And then we add our 5 over. So you have the log negative 8 divided by log 2 with a plus 5 on the end. If you type that in your calculator, remember we talked about the domain of a log, that the argument always had to be positive? If you type this in your calculator, it will tell you error, non-real answer. And so even if you didn't get it at the beginning, when you go to put it in the calculator to get your decimal, it will tell you there is no solution. You won't get a negative for an answer here. Okay. We're just going to keep working some of these. I want to do a couple that have a few more steps involved. So my bases are 3 and 0.4. There is no common base, so I add my log to each side. When you do that, exponents come down. Okay, this one is not as easy as just dividing by my log 3, because if you notice, you have x's here and here. We have to first get all those x's on one side. So over here, we have to distribute the log 4 to both. Sorry, log 0.4. So I want to take my two terms with the x and put them on the same side. So subtract over that x log 0.4. These aren't like terms because the arguments are different, but since they both have an x, you could factor out that x. Pretty ugly, but one step from the answer. X is multiplied with something, so to get x by itself, you divide. So my exact answer with the logs will look like this. If I ask you for a decimal, you have to be very careful when you plug this in. Every time you push the log, it opens a parenthesis, so you do have to close it. You also need a second set for your denominator. If you want to be on the safe side, put a second set around the numerator as well. Anything with multiple terms needs a double set of parentheses. So I would appreciate it if you would take a second and put this in your calculator exactly as I have it typed. So watch those parentheses. And if we do this, we should get a negative 0.5886 if you round up. And again, anytime you want to check these, all you do is go back to the originals. If you plug a negative 0.5886 into each side, you get 0.2736 on one side and 0.27437 on the other, so they're pretty close. And we know our answer is correct. Okay. Let's try another long one like that. Okay, so again, first step is to add the log. If you're comfortable with what's happening here, when you add the log, your exponent always comes directly down, so if you want to go ahead and drop that exponent, you may do so. If it's more than one term, please make sure you're putting it in parentheses. That way you don't accidentally confuse yourself. Because I do have x's on both sides, you're going to have to go ahead and distribute. This time we have to distribute on both sides. So we get 2x log 5 minus 3 log 5 equals x log 8 plus log 8. Okay, we have two terms with an x and two terms without. So what we're going to do is take every term with an x on one side and everything without on the other. So I'm leaving this 2x log 5. I'm going to subtract my x log 8. Over here I'm leaving my log 8. I'm adding my 3 log 5. On the left you have two terms, both have an x. They are not like terms, so you can't actually subtract them, but you can take out your x. So then, to get x by itself, you just divide. So your exact answer is log 8 plus 3 log 5 over 2 log 5 minus log 8. If I asked for a decimal, this is where parentheses, but be very careful. You need them after each log, as well as a second set around the numerator and the denominator. So take a second, put that in your calculator, make sure you do so correctly. And you get 6.0624 for your exact answer. Sorry, that's your decimal answer. Okay, just a few more before we stop for today. This one, we've done something like this already. Make sure before you add your logs you isolate it, so I first need to subtract my 1. Order of operations says you have to do exponents before you multiply, so I can't just take the 5 times the 1.2, so I have to divide it over. But 6 divided by 5 is 1.2, so we got lucky. If you get this common base, solve it how we do the common base problems. Drop your exponents, add your 2, and you get 1. Now, if you don't get a common base, that's fine. You just add your logs, but don't assume that every problem will require a log. A last example for today. We have to start out by combining these. I can't add a log unless there's only one thing on this side. Remember from our common base problems, if things are multiplied, you put them together by adding exponents. So 2x plus 1 plus a negative 4x is negative 2x plus 1. We can't get a common base, so we have to add a log. Because I have a problem with an e, I'm actually going to choose to add the natural log. That's not required, it just makes it a little bit easier. Because if you remember the properties, a natural log is log base e. And if you have log base e of e, they cancel. So really, if you have an ln of e, that drops and you have negative 2x plus 1. Now, if you added your regular log, you're going to be fine. You'll get the same answer. It's just going to look a little bit uglier along the way. So to get x by itself, we have to subtract our 1 and divide by negative 2. Again, if you do the calculator, parentheses around the 3, parentheses around the entire numerator. And we should get a negative 0.0493. Okay. So we are not done with this section. We will continue practicing these in the coming days, but that is where I'm stopping today. There is a Math Excel assignment posted, 6.5 day 1, so please do that. Due by 3 o'clock on